So we're here looking today at distance versus time graphs, and it's important to note sometimes the word position is used here. I tend to just say distance versus time graphs, but these could be used interchangeably. This we're one of the activities that is associated with in physics classroom is Minds on Physics KG2, although this little bit of information would not be limited to the assignment for KG2. It's just an overall overview of graphs specific to distance versus time graphs. Several different scenarios you would find here. First, to interpret a graph, if we could turn our eyes over here to this, on this physics classroom KG2, this question here, it's important to note that excuse me, there we go. Let's do blue. It's important to note that while it appears like things are going like uphill and downhill and curving, this is not at all what's happening. What's actually going on here is there is somebody at point 0, and then they travel down here. And when they get to here at point B, they just stay for a while. As time marches along, they stay at point B for a while. And then they travel back up this way. And then when they get to this point right here, they actually start slowing down. This was a steady rate. Then they start slowing down, but they keep going up here. And when they get to point E, then they just stay there for a while. And then they start traveling back down at a steady rate to point G, and then they just stay there for a while. And that's where the graph ends. It's important to note that this is just going back and forth. An example of what that might look like, if you look here, is if this guy starts at position 0 and we give him an initial velocity of -2, and then we press play, he's going to go down there. And then if we pause it, and now we give him a velocity of 0 and we press play, he's going to stay in the same place. And then if we press pause it, and then if we give him a positive velocity again, we'll say 3, and we press play, he's going to come on back up. And then if we give him an acceleration of, say, -2, and we press play, you'll see that kind of flattens out. And then we paused it, and we actually overdid it a little bit here, but hopefully we could have got to 0, and we press play. Could flatline it. So you can see how this guy has just been moving back and forth up here. We can play it back. Watch him as this graph is made. He's just going back and forth. This is what we're trying to see here. So pay attention and bear in mind that this is telling a story of something basically just moving back and forth. Now there are a few different things that you'll see here on a position time graph. I've made a list over here of most of those. Not moving is pretty much the easiest. As you can see, that would be shown here with these flat lines. Not moving. And of course, in that case, you think about the position. If we think about the position, nothing's moving over there. I don't want that. If it's not moving, the position is just standing in the same place, like at E, nothing's moving. So that's what an example of not moving would look like, is that flat line. A positive velocity, this means traveling in the positive direction, so that would be along point C here. This right here would be, it's moving at a constant positive velocity. A negative velocity would be something like this, where it's moving in the negative direction. So the object is moving downwards from positive to negative. So this would be a negative velocity. Slowing down would be right here. And the reason why we can say that is, let me erase this. The reason why we can say that is, slowing down and speeding up, I'll show you on this, might make the most sense. I'm going to reset all here. If we start with a position of 0 and a velocity of 0, and we give an acceleration of, let's say, 2. This is positive, so this object would be speeding up. We can watch it start. And it hit this brick wall. That's why we got that funky thing going there. I'm going to reset that without that there. We'll start out with a velocity of 1. And we're just going to play here. And if we're looking at this graph, we can see the slope here with a velocity of 1 is like this. What if we change that to, say, 10? Now, bear in mind what that is over there. I think I can do this. We'll see if this works. This is when it's at, this was at 1. Let's change this to 10. Well, oh my. We'll change this to 10 and see how that looks different. Now check that out. The difference, when this is at 10, you'll notice the steepness of the slope is dramatically steeper when it's at 10. So what that tells us is the higher velocity is, the bigger that number, the steeper that slope is. We would actually see the same thing if we had a negative in the opposite direction. Let's just change this to, say, negative 10, and we could press play. We're going to see essentially the same steepness, just in the negative direction. So when we talk about acceleration, so I got that erased when we come back here. If we're talking about acceleration, we're trying to look at speeding up and slowing down. What you need to think about is if you start with a velocity of 1 and acceleration of 5. So this object should be speeding up. Let's just play this. And I'm going to clear that because I forgot to have the acceleration at 5. I don't know why it didn't work there. Start at 0, 1. Let's try this one more time. Okay, I pause it. So what we're looking at here is, remember, the steepness of a position versus time graph, the steepness of that slope shows how fast it's going. So if you think about it right here, the slope of that is pretty shallow. But as time has passed, the slope of that has actually changed. So what's going on here with the curve, and I'm going to click here and then back to here to erase all that. What's going on here with the curve is the slope is changing. So this would mean you go from a shallow slope to a steep slope. This would be speeding up, positive acceleration. Likewise, slowing down would look a little different. Let's start with a velocity this time of 1. Again, we'll just be consistent and we'll see what slowing down looks like. And this time let's do negative 5, enter. And we'll pause it. So here you can see once again, slow. Check this out. Even though it's a negative velocity, it's actually increasing in speed because the slope is getting steeper. That would another be example of speeding up. And I'm sorry, I messed that up. I made that really confusing because where it was really happening, the slowing down would have been happening right here. Then it changed direction and I just misspoke there. Let me start this over. It would make a lot more sense if I started this number with a much larger velocity. Let's say we start with a velocity of 10 meters per second and then a acceleration of negative 5. So we should start out going up like this and we should see a better example here. Just kidding. For some reason that didn't take. I don't know why that cleared. Let's try it one more time. Oh my word. Okay. Some reason when I'm pressing play, sometimes these are just re-switching. I'm sure when I watch this video, I'll see what I was doing wrong. Oh, see there, it did it again. Clear. It just went to 0 on me. I'm going to reset all. I don't know why it's doing this, but start at 0, velocity 10, acceleration -5, enter. What we should see is what I've been trying to show you all along here. There you have it. You can see that the slope started out really steep and then the slope flattened out there. So this would be an example of it slowing down with that negative acceleration. The previous one I showed, I started too low, and even now this thing has changed direction. If we started showing it now, it's going to start speeding up. Since it's traveling in the negative direction right here, its velocity is now negative, and so that's why it's speeding up, because you have negative acceleration in the negative direction would be speeding up. So this is not always the case. You got to pay attention that you're starting out in the positive direction. I do believe that is the end of this video. Near as I was trying to show you a few of these things, I hope this helps. Thank you and have a blessed day.